All right. Hello. Hi. Wow, this is working. I'm glad. That's something I learned this morning. That's how it works here. So you greet people, they greet actually back. Um, I come from a long, long way. So I'm from Germany originally. I live in Spain now, but this is my first time on the African continent. So it's an honor. It's a pleasure, and thank you so much for the hospitality for having me here. Um, I don't have slides because I thought I will do something different. I show you directly what we're working on the Chrome team. So I work on the Chrome developer relations team, and we work on something called built-in AI. So I did something what we developers are really good at. So yeah, likely you have been on this webpage a bunch of times today, the next days, to plan what sessions to attend, where to go, what to do next, when lunch is, and so on. And I did something what we developers are really good at. I just took the page and copied and pasted it. So this is the original, and here is my copy. And you will notice, well, it's the same. It also has this fancy, fun yellow cursor, which is great. Um, but there's also a couple of new things that were not on the original page. And let me show you what they're good for. So first, we have a button here that says Français. And if I click it, you will see that everything all of a sudden just becomes French. And this was translated right in the browser. There was no API call, there was no server. This is an API that on the Chrome team, we're building directly into the browser. So this is the first thing that I added to the API, to the application here. The second thing is there's a button called Summarize Schedule. Well, if you look at the schedule, wow, it's very long. And we're all generation TikTok, so maybe there would be a better way to serve this rather than having us read everything here. So I built this little thing that lets me summarize the schedule. And when I press the button, you will see that it actually starts to summarize the schedule. So you can get a better overview of what is happening. Let me zoom in a little that you can see it better. So it summarizes this entire schedule and makes it a little bit more accessible. So instead of, this is the next API that we're building. So it allows you to summarize long texts into shorter texts. And you can see, well, it has done a decent job at summarizing what is happening today in Cinema Hall 1, 2, 3, what we can do, when registration is taking place, and so on. And the last thing I added was this little thing down here, which lets you ask things about the schedule. So as an example, we can ask which talks are about AI. So let's actually try this. Which talks are about AI? And based on the schedule, I then get a summary of all the things that today I could be looking at that explain things about AI. But I can also be like, oh, there was this one session, like the one right before mine, that talked about OSPOs. So some of you might be, what is OSPO? And you can see that it has the context. So based on the DevFest Lagos schedule, OSPO stands for Open Source Program Office. So you can see how this is aware of the context of what is going on here. And it really helps you interact with the schedule in a more interactive way. As you can see, I patched this directly into the page. If you want to play with this on your own laptops, this is the QR code. So it's on my personal, I call it throwaway GitHub repository. So things that I don't really need for longer. It's things that I need once. It won't work on mobile. So just as a fair warning, you need to have the Chrome browser on Windows, Linux, or Mac. And you need to have a certain amount of free disk space. You need to have enough video RAM. But we will talk about this a little later. But if you want to play with this, this is the URL that you want to bookmark. So how does all of this work? Some of you might wonder. And yeah, as I said, I patched this into the page. But if you look at the source code of this, whoa, it is not super easy to digest. So there's a lot of things going on. And it's not really fun to do this here. So what I did was I just created a small version of a page like this. And I really want to go step by step and explain to you what is happening. So let's start with the first step, basic. So if I go here, you can see already, well, it has sort of a speaker's biography. So you could imagine on a conference page, when you click on a speaker's picture, so just like here, if you go here and you go to speakers, this is myself. And here you can see like the biography. So imagine something like this, but very simple. So digest it to the absolute minimum. And the first API that I showed you was the one that could translate. So how does this work? It actually is super simple. It's actually that simple that I can show it directly in the Chrome DevTools. So if I open the Chrome DevTools and zoom this in a bit, we can start. And the first step when you want to translate something is you need to know the language of the original text. So for this, you need a language detector. And happens that we built one right into Chrome. So if you create it with crowd language detector equals await language detector dot create. So now we have a language detector. If you look at it, what it can do, oops, sorry, language, what is happening? Language detector. You can see that it is an object that we can interact with, and we can do stuff with it now. So we can, for example, go language detector dot detect, and this is everything async, so we need to call await before, and then we need something that we can translate, sorry, that we can detect the language on. And in my HTML, if I go here and I'll show you the biography, you can see it has an ID of bio. So whenever I reference bio, you know that I'm talking about this section here. So let's go back to the console here. So now I can go and say bio dot inner text, and this will now detect the language of the biography. So let's execute this. And you can see the result is a 2 elements array. And if I open that, you can see that with 99% confidence, the API has detected that the language of this is English, which is correct. So that's great. Now that we know the language, we can in the next step create a language translator. So let's do this. Pretty similar to before. Translator equals await, and then instead of language detector, now we have translator dot create. But this time I need to give it a source language and I need to give it a target language. So let's do this. So let's go source language, and you could imagine this is where you would hook up the language detector, but we have done it already, so we know that the language is English. And as a second step, we need a target language, and in the example we had French. So let's do French here as well. So now we have a translator that can translate. So let's actually translate something with it. So I go translator.translate, and again this is asynchronous, so I need to await it. And then just like before, I get bio.innerText, and oops, what did I do? Bio.innerText, and now I can execute this. No, what? Translate. I think I messed it up, so let me type it again. Translator.translate, and I need bio.innerText, and we need to await this. Okay, and now you can see we have the translation directly here on the console. And it was super fast, right? So we didn't really have to wait for it. But sometimes if you have really long text, there's also a streaming method that you can use. So let me show you this. So instead of translate, I can also use translate streaming. And this gives me back a stream. And the creation of a stream is not asynchronous, so I don't need to await it. So now I have a stream, and from the stream I can read from. So I can go for await, and then chunk of stream, And then I can just log each of the chunks to the console, console.log, and I can log the chunks. And if we execute this now, you can see that it has taken sentence by sentence and translated each of them. So this is the first two APIs, the language detector API and the translator API. Great. So we have this in the browser now. It shipped in Chrome 138. And what this means is you can now translate web pages without paying for a server. It can all happen locally, so you can also translate things like private messages because you don't need to send them to a server, which can be critical. So this is the first two APIs. So this means if you look back at our example here, this button, we have explained how it works. So the next thing, the summarize thing. So how does this work? And similar, it's also simple enough to be explained directly in DevTools. So by now you likely know the drill already. It's await summarizer dot create. And if we do this, we now have a summarizer. You will see it logs a console warning that I didn't specify the language, but we can ignore this for now because we know that it is English, so we can just work with the default. And what can we do with the summarizer? Well, of course, we can summarize stuff. So we can call summarizer.summarize, and as before, I give it the bio.inner text. And when I execute this, you can see I forgot the await, so let me fix the await. We then get the summary, and we get it in Markdown format. It's a little hard to read here, but you can see there's an asterisk, which means a bullet point in Markdown, and the first line goes until here. Then we have the new line character here, and then we have the next bullet point. So just like before, if you go back to here, you can see that we have a bullet point that summarizes a long text. Well, it was not that long to be fair, but for the sake of simplicity, into bullet points. So this is a summarizer. And just as before, I could use the summarize streaming, which is what you can see in action here. So if you go back and I press this button again, you can see how it streams in the responses. The translator did it sentence by sentence. The summarizer does it token by token. So let's very quickly do this. So I go summarize streaming, which gives me a stream. And now, just as before, I can recycle this. And well, you can see that it really token by token. So you can see this is a token, my name is token, and so on. All the separate things here get logged. A token is not really a word. So you can see here project is a word, F, and then fugu is the word, but the computer tokenizes it as FUGU. And yeah, you can see how the words and the tokens here stream in. So this is the summarizer, which means if you go back, we have checked this. So the final thing that needs explaining is, well, how the heck did this part work? And you can see on this page as well, we have a little input box here, so I can ask stuff about, yeah, in this case, the speaker. So I can say, I don't know, is the speaker qualified to talk about AI? Question mark. So let's see what we get. And the LLM tells me, yes, the speaker is highly qualified to talk about AI, particularly web AI. So you can see, well, it has made sense of the information that it had from the biography that I gave it. So now I can work with this. I can also ask, does the speaker have a blog? And now the LLM analyzes information. Yes, according to my information, Thomas Steiner has a blog at, and then it gives me the URL. So this is all working great, but how does it work? So what is the secret behind it? And for this, I could, in theory, do it in the DevTools and program it live one by one, but it's a little easier, I think, to follow if you just look at the source code here. So let me make some space like that. Okay, so let's see, with a zoomed in variant, it's a little hard, so I think this is the best we can do. Right, so we have our page here on the left, and we have the source code that powers it on the right. And the first 3 lines are just getting references to the HTML elements. So if we have a form, which is the form field that we have down here, we have the input, which is this, and we have the output, which is where the LLM generated output lands, which is this down here. Okay, and then for the form, we add an event listener on submit. And the next step is we need to prevent the default so that we don't actually submit the form, but we can handle it in JavaScript. And then we need to get the prompt. And the prompt is just the input value trimmed, so all the leading and trailing spaces removed. And if there's nothing left after doing that, then we return. So if, for example, someone just enters spaces and we submit, well, of course, there's nothing to do. So in this case, we return. But if we are still there, then in the next step, we reset the inner HTML to nothing. So we delete everything that is possibly down here. And now comes the actual thing. And before I showed you already the basic mechanics of all of those APIs, we await, and then in this case, we create a language model, which gives us access to the language model that we built into Chrome. And we need to give it a little bit more details. So we have the expected inputs, which in this case are of type text, and the languages are only English. So it's an array, so I could specify more than one language. But in this case, it only needs to deal with English, because as we've seen, everything here is English. And then the expected outputs are essentially exactly the same. So we expect text, and we expect this text to be in English. And then we give it an initial prompt, and in this case, we give it a system prompt, where we tell the LLM what it needs to do. So I tell it here, you're a helpful general assistant with special knowledge about a person called Thomas Steiner. And then I give it access to what we've seen before, the biography, so that in the system prompt, I brief it about the text that I have here in my biography. So like that, the LLM is aware that it is specially briefed on giving responses about a specific speaker. So going back to the beginning here, everything else you have already seen by what I've shown you before. We have a stream that we get from the language model. And in this case, the function that we need to call is prompt streaming. We pass it the prompt, so the value that we have here in the input field. And then we just iterate over the stream one by one. And it gives us what we've seen here. So we can ask one more question. Does the speaker use social media? And then it tells me, yes, based on information, blah, blah. So it really understands what I'm saying, like understands in the sense of how an AI can understand things. So this is the first basic step. But of course, there's more. So if I go back, the next step that I can teach you about is the JSON schema step. So you have seen I've asked a bunch of questions that had either yes or no as an answer. So I asked, does the speaker have a blog? Does the speaker use social media? And in many cases, I don't want the full response. So like I don't need the entire blah, 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 yada, yada, yada. I just need true or false, because sometimes I'm building some sort of classifier and I just need true or false. How can I do this? With something called JSON schema and with a response constraint. So everything is the same as before until here. We get references to the HTML. But now we have a response constraint. And the response constraint is created in JSON schema. JSON schema is a way to express how you would like a JSON method or JSON object to look like. And the simplest possible JSON schema is just this type Boolean, which means we force the LLM to respond with just true or false, so a Boolean value. You can have a lot more complex JSON schema. So if you need an object that has certain fields and a number of entries in an array and blah, you can define this in a JSON schema that becomes relatively more complex. But in this case, I just wanted to keep it super simple. So here the form is exactly the same. This is exactly the same. The prompting is exactly the same. Resetting the HTML is exactly the same. Language model creation is exactly the same. The one thing that is new from before is this. Now we pass it the response constraint. And the rest here is also exactly the same. So let me show what this does now. So if I go here and I ask, does the speaker have a blog? Question mark. You can see that now, instead of the very long blah blah, yes, the speaker has a blog at this and that URL, now it just gives me back true or false. So that's very useful already, because like that, I make use of the LLM, but I control the LLM output, which is I get structured output from the LLM, which means I can make the processing of the LLM's answer a lot more simple. Okay, so let's get back to here. The next step that I can show you is multimodal. We have an image here. That first 3 lines are the same as before. We get the form, the input, and the output. But now I also get the image. So I'm getting a reference to this image that is very slowly loading here. And next, we create the form with the submit listener. We prevent the default. And now you can see the first change. So before I had a text alone, but in the next step, I will have text and another modality. So in the next step, I'm also adding an image, which means in this case, I'm renaming my input prompt to just text prompt. And then in this step, I'm forming the actual prompt, which is now an array that has the role of user. So it's input that's coming from the user. And now we give it the type text with the value of the text prompt, just like before. But I'm also adding a new modality, which is image, with the value of the image that we have here. And this is the creation of the prompt. So now I need to actually create the language model, which happens in this step. And now I need to tell the LLM, instead of just text, you can now also expect images. So here I change the expected inputs to have type text, language is English, just as before. But now I'm also telling it, by the way, there's also images coming. The output is the same as we had before, so type text, language is English. The system prompt is the same. This part is the same. But now we can ask about the speaker and about the image. So let me actually demonstrate this. So, well, you've seen the image now, so I can ask something like, where is the speaker standing? And the LLM starts looking at the image and says, based on the image, the speaker appears to be standing on a beach. This was a beach in Belgium, by the way. And it describes the image. The background shows sand, water, likely the ocean or a large lake, and a cloudy sky. So, of course, it doesn't have exact information where it comes from, so it can't it can't really pinpoint the exact specific location. But you can see it already does work with the image. I can also say, like, describe the speaker. And now it tells me, well, the speaker works at Google, blah, blah, blah. And then the physical appearance. He's a fair-skinned man with reddish brown hair. The image shows a somewhat windswept look. He has freckles on his cheeks and nose. He appears to be average height and build. He's wearing a green and brown baseball hat and so on. So you can see it really has an understanding of what is happening in this image. So that's the multimodal part. So now we can ask about the speaker. We can ask about the speaker's avatar image. And now we can bring both of them together. So if I go back one step to the final step, JSON schema and multimodal, I need to wait for the image again. So actually I can likely just say I want to enable the caching. So let me get back to here and load it. Okay, now it's loading the image. It still doesn't get it from the cache because I had the checkbox checks before. But anyways, what I'm doing now is I'm combining multimodal with the structured input response constraint that I had before. So what this means is I can now ask questions about everything, the biography, but also about the image, and get yes or no as an answer. So let me just first show it. So I can say, does the speaker like hats? And it tells me true, because on the image I'm wearing a hat, so it's very likely that I like hats. I like them, but I also need them because they get burnt easily by the sun. So I can then still, as before, does the speaker use social media? and it also tells me true. So how does it work? Let's jump into the source code. So it will be very familiar with the previous steps. We get HTML, we have the response constraint that we've seen before. Here we have the image, getting the image reference. We have the form with the submit list layer, we have the prevent default, we have the text prompt that we create, we have the actual multimodal prompt with the text and the image. We have the resetting of the output element down here. We have the creation of the language model. We tell it needs to accept images and text, everything in English. We have the system prompt, just like before. And the only new thing now is the response constraint that we bring in. And with this, we can actually combine everything. So we can have multimodal and we can have true, false, structured output. So this is, of course, really just a toy example, but you can see in practice at this toy example how it could be useful. Like imagine you have this web page and you let people ask about the schedule. So we can also do stupid fun things with it. Like we can ask it, who is the coolest speaker today? So let's see. So I swear you, this was random. So this, of course, completely stupid. It's just a fun query. But, well, apparently I'm the coolest speaker today. So let's ask about tomorrow. And now we got about Tabi. About Tabi in the room? No? Maybe arriving tomorrow only. Well, about Tabi apparently is the coolest speaker tomorrow. Is Moses Ogunranti in the room? Also maybe only arriving tomorrow. So anyways, this kind of stupid things you can do with it. But like you've seen the cool serious things. So I can ask about what is Web3? So a lot of people here are talking about Web3. And now I can see, well, I can use this actually for useful things. This has barely scratched the surface of what you can do. All those APIs, we are starting to build them into Chrome. The Summarizer API, so going back to my images here, so the Summarizer API, the thing that powers this button, the Translator API, and the Language Detector API are in Chrome as of 138, so quite a while ago by now. The other API that I showed you, this one, we call it the Prompt API because it allows you to prompt an LLM, is in origin trial right now, so which means you can test it with real users, but you need to sign up in order to test it. We're working on a bunch of other APIs, and before I jump to there, I also just wanted to give you the QR code of this, if in case you want to play around. Let me actually stop. Before you scan it, let me go to the root, so I can really go chapter by chapter. So I wanted to give you the QR code for this. So if you want to play with this and understand at home how it works, this is probably one of the simplest ways to learn about those APIs. And then next, I want to leave you with our documentation. So let me pull up the QR code for this. So this is a landing page for all the different APIs that we are building into Chrome. So you can see I showed you the Translator API, I showed you the Language Detector API, the Summarizer API, but we're also working on other APIs like the Writer API, the Rewriter API. I showed you the Prompt API. There's a Proofreader API that we're working on. So if you're interested in any of those, this is the QR code that you want to scan. And with that, thank you very much for listening. I think we have time for questions. I'll be around all day. Thank you so much.
Thank you very much for your presentation. So, my question, let me just try and put them together. So, do we have a choice of models to choose from? So, for example, can we choose between what we have, like the defaults, maybe like Claude or ChatGPT? That's yeah. Okay. Then
Let
data
me
privacy
maybe
policy.
answer this question right away.
Okay.
Or you want okay. So the question was, can we choose the model? And the answer is no. The reason is, why do we want to make this so simple? Because the browser knows pretty well by looking at the use cases, like we've seen here, summarizing, translating. This is all well-defined use cases. So the browser knows pretty well what is a model that works for these use cases. And we make it so that the browser downloads the model on the first attempt to use those APIs. So once it's downloaded, it is available for everyone, which means as a JavaScript developer, you don't need to care about downloading the model. You don't need to care about updating the model when a new version launches. Because the browser takes care of all of that, it also means you don't have to deal with all of these complicated things. In Chrome, we use a model called Gemini Nano, which is from the Gemini family, but a really small one. We call it a small LLM, so a small large language model. But yeah, we don't allow you to choose. But the reason also is, once the model is downloaded, all of the single origins can use it. So whatever web page you go to, it can already use the model. You don't need to download a new one because we share it across the origins.
Okay, yeah, and maybe let me just make it my final question. So, data privacy and security concerns. Now that you've mentioned that the various tabs, so the processes can kind of share the same model. So, what are like some of things we should look out for? Thank you.
So the question was about the privacy and the security aspects. So none of the information that you enter in the LLM leaves the browser. So everything stays local. So just for the proof, if I open the network, you can see I'm making requests and things start loading. If I go here, you can see I have the HTML, the CSS, the JavaScript, and my image. And if I make a request now down here, so I can say anything like, tell me a joke about Tom. It starts doing the thing, but well, there's no network request, so everything remains local. So all is local processing, which also means, as I said before, if you have something like a chat client, right? So you have direct messages, for example, that are meant to be end-to-end encrypted. You can also translate them with the translator API because none of the information leaves your browser. If you are on example.com, you can tell the model, hey, example.com, I have cancer. And this information stays at example.com. If you go to insurance.com, they don't know that on the other example.com you told the model that you have cancer. Because else, if they knew, they likely would not insure you because they're, they want to make business. They don't want you to stay healthy. They want to make business. So they need healthy people. But because they don't know this information, because it's all private to the model, this is another privacy aspect here. It also means you can't teach the model. So you can't teach the model globally something about you. That's something we are considering adding as a special, like giving context about you or about whatever the matter of subject might be. But by default, everything you tell the model stays private. So there's no way that this could be leaked.
Yeah, I wanted to ask if there's a kind of a cost per usage of the whole system,
I'm not sure if I got
like the cost.
Oh, the cost. This is all free. And why is it free? Because we deliver the model to you, but then the inference, which is what costs typically money when you go to the cloud, if you go to Gemini.com or ChatGPT or whatever, the processing here happens locally. You can actually see this if you look at the GPU activity. So if I go to here and I say activity monitor, and I go, well, it's Windows has it. We don't have it here. Let's see, CPU. Is there no? No, I can't show you. I can't show you on Mac. On Windows, you can see the GPU activity. But like when you do a calculation, when you do inference, it's all happening locally. As I've shown you, there's no network request, which means the user of the web page pays by doing the calculation locally. But for you as a developer, there's no cost. There's no API keys. You can just use the API directly. If you're interested in hearing about all of those new things, we have something called the early preview program.